Hi ladies and gentlemen, this is Mrs. Poland for lesson 1.04 on representing quantitative data with numbers. We're on example 2. A researcher is interested in how much annual rainfall is typical in the U.S. She takes a random sample of 9 cities in the U.S. and records the annual rainfall in inches. And so they provide you with the data, and for the first part of the question, they ask, calculate the mean annual rainfall for these cities. So you're going to go into your graphing calculator, and we're going to go home. You're going to always enter a new document. Don't save what you have unless it's something you want to keep. And you're going to add option number 4, add list in spreadsheets. That's where you enter your data. You're going to enter either the variable name X or be more specific. I'm just going to enter X. Make sure you get out of that cell. The row before the variable, after the variable name is a formula row. At this point in time, we're not going to use it. We're now going to start entering our data carefully. So the first number is 8.2, then it's 10.2, and let's continue entering. Once you enter the data, you're then going to hit Control Page and enter a calculator page. So 1.1 and 1.2 are linked together. So now you're going to hit Menu, Option 6, that's where we'll be most of the year. Option number 1 for stat calculations, and we're dealing with one variable in this case, and that's rainfall. We have one list. We're going to hit OK, and we're going to either type in the variable name or just hit the drop-down menu. We're not dealing with the frequency table, but if we were, you would set up a variable for frequency and enter it there. Right now, we're not going to be dealing with category lists or include categories. That's something you would use if you were dealing with more detailed data entries. When you press OK, you get your results. So X bar is the sample mean. Sigma X and sigma X squared are functions. We're not going to be really using them. SX stands for the sample standard deviation. Sigma X stands for the population standard deviation. Lowercase n is the sample size, 9 in this case. Minimum X is the minimum value, or 8.2 inches. Quartile 1 represents 25% of the data. 4.5 is the median. 43.65 represents quartile 3, and they give you the maximum value of the data. SSX, we're not going to be dealing with at this point. So now let's go back to the prompt, and a lot of times students will ask me, well, what should we round to? Because generally in AP statistics, they don't tell you. So it's a good practice, and this is how we will be running our class, to carry things out to at least 3 decimal places. So the sample mean would be 34.933 inches. It's really important to include units. So we represent the mean by X bar. And that's 34.933 inches. Quartile 2, as we mentioned before, or the median, is equal to 40.5 inches. And now we're addressing the next question. What would you use the mean or the median to summarize the typical annual rainfall for a U.S. city? Explain. Well, we notice that the histogram on the right is skewed to the left. Because of the skewness, the more appropriate unit of measurement would be the median. So we're going to use the median to represent the center of the distribution, since the distribution is skewed to the left, and the center therefore would be affected by low rainfall values. So the mean, if you used it, would be affected by these low rainfall values. They now want you to calculate the standard deviation. Well, we already received that calculation when we calculated the mean, but now you have to make a decision. Are you going to use the sample standard deviation, or are you going to use the population standard deviation? Since the problem, we're only given a sample of 9, and we don't know all the rainfall of all the cities, you would use the sample standard deviation as opposed to the population standard deviation. So the sample standard deviation was equal to 15.5 inches. But not only did they want you to state the actual numerical value of this standard deviation, they also wanted you to discuss the interpretation of it. Well, in general, what is standard deviation? Standard deviation represents the typical distance each data value is from the mean. So we have a sentence frame that you may, a lot of my students like to use. And so the blank, you're going to enter the context here, typically varies by, and you're going to enter the value of either the sample standard deviation or the population standard deviation, depending on what the problem's asking for, from the mean of blank. So in this case, the annual rainfall, that's the context, typically varies by 15.5 inches from the mean of 34.933 inches. And notice I'm including the unit. Just finally on the lesson, I just want you to turn your attention to whatever's in the box. So in this lesson, we calculated the measures of the center, the mean and the median. We also calculated measures of variability, the range and the standard deviation, and that's again for quantitative data. We also talked a little bit about how outliers can affect the center and the spread. Measures of center are the mean, median, and mode. Measures of spread or the range. We're going to talk about the interquartile range in the next lesson, and the standard deviation. The standard deviation represents the typical distance each data value is from the mean. And although they give you this formula on the AP statistics exam, it's helpful to actually see it, but you will not have to do any kind of manual calculation of the standard deviation in this course, aside from that one model problem I showed you. Okay. I also give you the interpretation. So here's the sentence frame. The blank, whatever the context is, typically varies by, and you're going to give a numerical answer, from the mean of X bar. Note, when do you get a standard deviation of equal to 0? Well, remember, standard deviation is the average distance from the mean. So it turns out if each data value is exactly the same, there's no difference, and therefore you would end up with a standard deviation of 0. Have a nice weekend, ladies and gentlemen.